In this lesson, we'll talk about the programmable graphical calculator, the calculation facility which is available in GraphicCalc 2010. We call it a programmable graphical calculator because you can include geometry and dimensions directly into calculation statements. To show you the concept, let me just create some geometry here. There are three circles, and let me put a dimension on this circle. So I want the radius of this circle to be equal to the radius of this plus the radius of this. Of course, you can enter in the formula bar, but this is just to illustrate how the calculator works. So the calculator is open from under the edit menu, and you have to give a calculation name, and the calculation name has to be specific, and I'll explain that to you in a second. So the calculator opens is an x equal to function y type of calculator. So let's make a small program here. B is equal to thing, and the last line has to be the name of the calculator because that's where the result will come in. So then place the cursor next to the equal to sign and then click on the enable link command. Now the calculator will accept an input from the worksheet, so just click on a geometry. Likewise, let me move this up a little bit. Click on the enable link command. The enable link has to be activated for each insertion of the geometry because this way you will avoid errors due to unnecessary clicking on the entities or geometries. So B is equal to the radius, so you can put the radius value in there. Let me just put a cell also here. So let's say there's a cell here which is 5 millimeters. So I'm going to extend this calculation, and let's say C is equal to the value of this cell, and ABC is equal to, let's say, A plus B minus C. So it's a small program I've generated, and then when I say recalculate, it gives me the answer. So now I can take this circle here and select the freedom I want to control with the calculator, and then click on the formula bar, on the value bar to activate the formula bar, and then just click on the calculator. So the radius now will be driven by the calculation here. So if I change the geometry now, for example, you'll see the calculation is updating in the calculator. And once you have set up the calculator, you can close it and it'll work in the background. And the nice thing is that any calculation that you set up in GraphicCalc 2010 calculator, you can validate your calculation. And if I save this, let's say a test file, then if I start CAD calcs, I can load the test file. Notice there is no calculator in CAD calcs, but the calculator can work in the background here. So this is a very interesting facility. So you can have a combination of CAD calcs and GraphicCalc distributed in your organization, and then you can set up a library of calculations, validated calculations in GraphicCalc, and then those worksheets can be used in CAD calcs. Also, you can use CAD calcs, for example, to do a customer demo. You don't need to have the full access to the calculation facilities. So that was a straightforward thing. Let me open the calculator again. You can also connect multiple calculators. Let me just make it a little smaller. And let's say I'm going to start another calculator, and let's call it, let's say, XYZ. Okay, and here let's say A is equal to 5 millimeters, and B is equal to something, and then XYZ is equal to A plus B. So here I can say enable link and bring the cursor here and then click on this calculator. So the value of that calculator will now go into this. So when I say recalculate, you can see this calculation is, these two calculations are linked. That means this calculator's value is driving this calculation here. So if I change, for example, the geometry here, you notice both the calculators are updating. And also when you click on the copy results command, it just makes a copy of the statements and the results and puts it in the Windows clipboard, so you can clip it into, you can then paste it into Excel or into Word or any Windows standard application. The other nice facility is you can declare arguments in the calculator that you call at runtime. For example, I will set up a calculator here, and let's call it ABCD. So let me name the arguments first. So I can name arguments X and Y. The arguments should be named in the same sequence they will appear in the calculation. So I can say A is equal to X and B is equal to Y and ABCD is equal to A plus B. So if I do a recalculate now, this shows as not available. But when I call this calculator, I can put the arguments. So I will click on the calculator here, but here I'll put my cursor within the parentheses, and let's say I put 5 for X and comma 7 for Y. So when this calculation will now be evaluated, you notice that the arguments were substituted. So you can really use the calculator to create subroutines of your frequently used calculations. For example, Snell's law or certain stress calculation or deflection calculation. You can make these templates, and then the worksheet containing the calculators can be used by anybody in the organization. Let me show you an example of how the calculator has been used in real life. So here the windshield wiper mechanism, the blade holder itself is using the value generator to move it from 5 degrees to 2 degrees increments 85 times. But if you notice, the crank here is driven by a calculator which is communicating with the geometry. So the crank angle is a function of the blade holder's vector. The blade holder is the geometry here. When you double click on any of the entities in the calculator, it highlights the corresponding entity in the worksheet. So this really opens the software out, because you can connect multiple calculators to create some very powerful problem-solving platforms. There's another example here. Of course, this is a pretty advanced usage. Here, the complete four-wheel steering mechanism is being simulated at the system level, and the user has set up a whole lot of calculators here. This is from I believe in Netherlands, so the language is Dutch, but you can see the calculators are really pretty heavy-duty stuff going on. And so, because the calculations can also be read in CAD calcs, the worksheet operates in CAD calcs, and you can just display the variables in cells outside that affect the calculations and use them in CAD calcs also. So it becomes like a groupware, so you can mix and match the solving power in the organization. Thank you.